Hi and welcome Pure Math 3 students. We're on week 15 of our maintenance, and the first one is an algebra question. We're trying to turn this fraction into partial fractions. So, of course, go back to your textbook if you need to, but we're going to be writing it in this form here, plus bx plus c over x squared plus 4. And this leads us to the numerator must be a times x squared plus 4 plus bx into 3 minus 2x plus c into 3 minus 2x. And that's equivalent to this 5x squared plus x plus 6. Now, what I do is I'm going to first of all, let x be equal to 3 over 2. And when I do that, that will mean that you can see that this will drop out and this will drop out because those brackets will equal 0 and 0 times anything is 0. So then I'll get 3 over 2 squared plus 4a, which happens to be 6.25a. And then I chuck in the 3 over 2 for all of the x values there, and I get 18.75. And therefore a is equal to 3. And then the next bit that I would probably do is I would equate the coefficients for the x squared terms. Okay, there's only, if you look at it, a couple of ways that we can make an x squared term. We could times a by x squared, or bx times negative 2x. Those are the only ways that we get an x squared term. So we know that a is 3, so 3x squared plus, and then, well, it would be minus 2bx squared, and that's got to be equal to this value here, isn't it? Because that's how many we have altogether, 5x squared. And you can see, therefore, that b is equal to minus 1. Because minus 2 times minus 1 gives you positive 2, and 3 plus 2 is 5. So that's nice. Once we know that, we could also equate the coefficients for the x terms. Sorry, my writing is a bit off this morning. So if we look at the ways of getting our x term, we can go bx times 3 and c times negative 2x. So we could say, well, we know b is minus 1, so we get negative 3x and then minus 2cx, and that's got to add up to just 1x. So that means that you can see that therefore c is equal to negative 2. And so at this point we've got everything we need. We've got 3 over 3 minus 2x plus negative x minus 2 all over x squared plus 4. So far so good. Now we've got to now obtain an expression for the expansion of this in ascending power. So what I'm going to first do is I'm going to start off with this one here, 3, and instead of putting it over 3 minus 2x, I can rewrite it like this, to the negative 1, and then I've got to take that 3 out, so I'm going to go 3 times 3 to the negative 1. Now I've taken that 3 out, so I end up with 1 here, minus 2 over 3, x to the power of minus 1. And you can see now I can just expand that. Well, the 3 times 3 to the negative 1 just cancels out, doesn't it, really? Alright, so we're going to get 1 plus negative 1 into negative 2 over 3x plus negative 1 times negative 2 all over 2 factorial into negative 2 thirds x squared. Okay, so that's that one done. And what does this give us? It gives us 1 plus 2/3 x plus 4/9 x squared. Okay, so that's that one. Now we want to look at this bit here. So I would rewrite it like this: minus x minus 2, and we're timesing that by x squared plus 4 all to the power of -1. Or I might even just rewrite it. Oops. Let's just rewrite it so that the 4's first, like that, to the -1. Now, we're trying to get powers up to x squared, so we'll keep that in mind as we work on this. Okay, so you can hear my children having I don't know if they're fighting or playing in the background. Hopefully playing. Okay, so we'll take that 4 out by timesing by 4 to the -1, and we'll get this 1 plus x squared over 4 to the power of -1. So in my next line I'm just going to have 1/4 to -x minus 2, and then I'm going to expand this bracket here. And the way I do that is I'm going to have 1, and look, I only need to go to the x, let's have a look, yeah, I only need to go 2 terms really, so I'm going to go 1 plus and then -1 times x squared over 4, and then that's as far as I need to go. I'll show you why in the next line. So 1/4 -x -2, and then we've got obviously 1 minus x squared over 4. Now I'm going to expand that quarter out, so I'm going to get -x minus 2 into 1/4 minus x squared over 16. Alright, now you can see why I've only gone that far, because we're only going up to x squared terms, so any more and I'd be wasted, because my next term in here would be x to the power of 4, wouldn't it? Okay, so now we've just got to see what terms we can make. So our non-x term is going to be this times this, so that's I think that's negative, yeah, it's -1/2, -1/2, -1/2, and then the next one will be this one, plus x over 4, oh sorry, -x over 4, won't it? -x over 4. Sorry, it's a bit distracting having the kids making all this noise in the background. Okay, and then the last one will be when we get an x squared term, which will be this one here. So that'll be plus x squared over 8. Okay? Now, all we need to do is put everything together. Okay, so this and this leaves me with 1/2. This and this leaves me with positive 5/12 x. And this and this leaves me with 41 over 72 x squared. And there we are. So that's that bit done. Hopefully that makes sense. Okay, so for the second one, we've got to use the substitution u is equal to 4 to the x, and we're going to use it to solve this equation here and give an answer to 3 significant figures. So I can rewrite this as u plus, I'm just going to go to 16 equals, now you can see that this 4 to the power of x plus 2 is like 4 to the power of x times 4 to the power of 2, isn't it? Oh, 4 to the power of 2. That's what it is, and we use our index laws to add those two together there. So what I can therefore write, I can say this is like 16, which is 4 squared u. Okay, because this bit here is u, and this bit here is 16, and they're multiplied together. Okie dokie. So then I'm just going to pull the u across to the 16u. And so I get 16 is equal to u into 15. And so u is equal to 16 over 15. Now, that means that 4 to the x is equal to 16 over 15. I'm going to use logs now. Log base 4 of 4 to the x equals log base 4 of 16 over 15. So x is equal to, and when you chuck that into your calculator, what do you get? You're going to get 0.0466 to 3 significant figures. The next one is a trigonometry question, and we've got to express this in the form of r sine theta plus alpha, and we've got some information here. Alpha's got to be between 0 and 90, and we need the exact value of r, and so exact value of r, and a corrected to dp. Okay, well, if we were to expand r sine theta plus alpha, we would get r sine theta cosine alpha plus r cosine theta sine alpha. And this leads us, this is using this rule here, isn't it? The addition rule. That means that we can say r cosine alpha is equal to 3. And we can say that r sine alpha is equal to 2. And therefore tan alpha, so if we put this over this, we'll get tan alpha, is going to be equal to 2 over 3. And so alpha is equal to inverse tan of 2/3, which is giving me 33.69. And to get r, remember we can square both this and this, right? So we end up with r squared cos squared alpha plus r squared sine squared alpha equals 3 squared plus 2 squared, and you can factorize out that r squared, and you've got cos squared alpha plus sine squared alpha equals, on the other side we've got, what's that, 9 and 4, 13. And you know that this, of course, here is 1, isn't it? So that's good. So r is equal to the square root of 13. Okay. So we can now express it in the form that we are required to. So it's square root 13 sine theta plus 33.69. And then we're done. Okie dokie. Now we're going to use this to solve the equation. So what we'll do is we'll write the form that we've moved everything into, like this, and we'll set that as equal to 1, and we rearrange it so that we have 1 over square root 13. And so we should get theta plus 33.69 is equal to, and what do we get for that? 16.1. Okay, now let's have a quick look. What I like to do is I just change this here. So if I'm actually going to be theta plus 33.69, then I've got to add to the bottom. So my lowest value is now allowed to be 33.69, and my top value I add 33.69. So that's my new range. And then I just draw my sketch of sine. I've got a 16.1 here, so obviously there's going to be one here at what's that? 16.1, and that'll be 180 minus 16.1, so 163.9. And you can see that those are the only ones that are going to be in our value. We can actually ignore this one because 16 is lower than the 33.69. So then the last step to find out what theta is to subtract the 33.69. So I do that now. And that's 130.21. Okay. Nextly, we've got to do some differentiation. You can see this is going to require us to use the product rule. So I'm going to first of all say that u is cosine x, and so du dx is equal to negative sine x. V is equal to cosine 2x. dv dx equals negative 2 sine 2x. And then we use the product rule. So remember, it's u times v, so negative 2 sine 2x cos x plus v, which is times du dx, so negative cos 2x sine x. And probably what we want to do at this point, I suspect, is use, let's grab this here, the double angle rule to help us out. So I could, and we want to find the coordinates of the stationary curve, stationary point of the curve. So we know that the gradient is 0. Now let's say, what is sine 2x? Another way of writing that is this here. So I'm going to go negative 2 into 2 sine x cos x, and then I'm timesing by cos x there. And then I've got plus, now, negative sine x, and I want to go, I'm going to now turn this cosine 2x. I'm going to probably use, I think, this one here and get everything into cosines. So that will give me 2 cosine squared x minus 1. Next line down, we'll get negative 4 sine x cosine squared x, and then we'll go minus sine minus 2, minus 2 sine x cosine squared x plus sine x. And you can see that there's a common factor of sine x in each of these, so we could just divide that all out right now, couldn't we, really? So the next line, 0 is equal to negative 6 cosine squared x plus 1. Or then we could rewrite that as 6 cosine squared x equals 1, cosine squared x equals 1/6. Cosine x is equal to plus or minus the square root of 1/6. And now what do we get when we do that? Square root 1/6. 1.15. Yeah, we can ignore the negative one because it's outside the range. It ends up being 1.99, which is greater than pi over 2. Okay, so that's where the x-coordinate of the stationary point is at 1.15. Okay, so this integration one that we're working on now, we're using a substitution. This is our substitution, and that's hopefully going to allow us to go from this somehow to this. Okay, so let's work through this step by step. I can say if u is equal to 2 minus square root x, I can say that square root x is equal to 2 minus u. I can also differentiate du dx is equal to negative 1 over 2 square root x. And therefore dx is equal to, now I'm just going to rearrange this, is equal to negative 2 square root x du, like that. Okay. Now we're pretty good to go, I think. So excuse me. So we know that I is equal to the integral of 1 with limits 0 and 1, and we've got square root x over 2 minus square root x dx. The first step is you can see that this here can be replaced with that. Okay, so that bit there comes 2 minus u, and then we can replace this bit here, that's equal to u, and this dx bit we've got here, now, what does that look like for us in the next line? I equals, and then we've got our limits here. Now, maybe I could go back to the previous line. This bit here, negative 2 times square root x. Well, we know what square root x is anyway, don't we? Square root x is 2 minus u. Okay. So, you can see that this 2 minus u and this 2 minus u will end up giving us 2 minus u all squared. We can have this negative 2 du u. And you can see that we're pretty close to what we need to have at this stage. You'll notice we've got this funny negative here. Now what I'm going to do in my next line is I'm going to take that out. So I'm going to have perhaps first, what I might do is I might change these limits, okay? I'll take that negative and put it outside here for now, and I'll show you why in a second. Now, when x equals 1, u equals 1, and I'm using up here to help me, when x equals 0, u equals 2. So this will lead us to our next line. I equals negative, and then we've got Now you've got to replace it carefully. So when x is 0, I've got a 2 here, doing limit 2, and a 1 here. And now I've got 2 into 2 minus u all squared u du. And now I'm just about there. See this minus here, because I'm timesing the whole thing by minus. That is, I can just actually now swap these limits around. So I get I is equal to, and then I have that limit there, that one there, because that's the effect that that minus would have. And that now we've actually got what they wanted us to get. Okay. Now I've got to show that I is equal to 8 ln 2 minus 5. So, well, how are we going to integrate this? So probably what I would do first would be to expand the bracket here. So I'm going to get 2 into 4 minus 4u plus u squared all over u du. And in the next line, we can write that as 8 over u minus 8 plus 2u. Is that right? Yeah, I think so. And then du. Okay, and now I'll integrate them. So 8 over u, that's like 8 ln u when we integrate it. Then when we integrate the minus 8, it's negative 8u. When we integrate the 2u, that becomes u squared. And our limits are 2 and 1. So this gives us 8 ln 2 minus 16 plus 4, take away 8 ln 1 minus 8 plus 1. Now that gives us 8 ln 2 minus 12 plus 8, so negative 4. I think negative 5, and that's it, because this of course is 0. Alright, so that's that one. That was pretty good. Well, the next one, we know that x satisfies the equation tan x equals pi minus x, and we know that there's a root between 0 and half pi. So what I'm going to do is I'm going to rewrite the equation tan x minus plus x minus pi is equal to 0, and then when x equals 1, tan x plus x minus pi, what does that equal? Negative 0.584. And when x equals 1.3, tan x plus x minus pi equals 1.76. The sign change indicates that a root lies between x equals 1 and 1.3. And now we're going to use the iterative formula to help us find this. I'm going to use my first value is 1.1, and then I'm going to type into my calculator this formula here and replace that with ans. First step on your calculator is to press 1.1 equals, and that will now be set to the answer, for and then type out this iterative formula, and then just press equals each time. Just like we did in class. So I'm getting x2 is equal to 1.1153, x3 equals 1.1123, x4 equals 1.1129, x5 equals 1.1128, x6 equals 1.1128, x7 equals 1.1129, x8 equals 1.1128. Okay, so it looks like we can say this is 1.1122 dp. Alright, I hope that's been helpful, guys. It was a few tricky ones in there this week. Let me know if you've got any questions or if I've made any mistakes. Take care. Bye.